Circuits are easy. Find the total resistance, parallel, series, all good. What if I add two sources into your circuit? One that's a voltage source and one that's a current source. What do we do now? We're going to use the principle of superposition. And yes, it's very similar to the classical physics principle of superposition. To solve this, we're going to split this whole scenario into two stories. Story number one is where we only look everything from the perspective of the voltage source and we shut down the current source. In the case of closing down a current source, you make it an open circuit. So in reality, the circuit is just two resistors in series, R1 and R2, since R3 is open. Using Ohm's law, we can determine the total current in the circuit and hence finding the current that goes through resistor 2, 15.6 milliamps. Then we take story 2, where we shut down the voltage source and make it into a short, i.e. it's connected. We don't need to calculate the total current because we have a current source, not a voltage source in this case. We can simply use the current divider equation to find what the current going through R2 is. Since from the point of the current source, it meets R3 first, then it splits into R1 and R2, and that is where we're splitting the current. Using the current divider equation that I derived a few days ago for you, you get 46.9 milliamps. And this is where the principle of superposition comes in. Because to determine what the current going through R2 is, it's simply the sum of those two stories we figured out earlier. Happy circuiting!